Good morning, everyone. Now we will start the revision on our quarter 3 to be ready for the your quarter exam. Firstly, there is some points you must save it. You must know the law of speed, which represent pi distance over time. D divided time. And remember the law of acceleration. Acceleration equal v2 minus v1 divided by time. v2 is the final speed, v1 is the initial speed or the start speed. And know the law of work equal force multiply distance. Work equal force multiply distance. And remember the law of power. Power equal E, which is amount of energy. E is the first letter of the word energy, divided by T, which is time. So power law equal energy divided by time. And the law of kinetic energy, which is equal have mass multiply speed square. Again, kinetic energy equal have mass multiply v square. And the law of potential energy equal mass multiply gravity multiply height. You can find the law of potential energy in your sheets, which uploaded on your LMS in topic March. You find that potential energy equal mgh. M, the first letter of mass, G, first letter of gravity, H, the first letter of height. And the final law in your curriculum, mechanical energy equal kinetic energy plus potential energy. And you must remember the measuring unit of each one of them. Speed measuring unit meter per second or kilometer per hour, kilometer per hour or meter per second. The measuring unit of acceleration meter per second power 2 or kilometer per hour power 2. And the measuring unit of force is Newton. The measuring unit of energy and work, both of them are similar, both of them measured by joule. And the measuring unit of power is watt. Measuring unit of power is watt. Let's start our revision. The first question, you can find that this revision sheet is not the same you have on your LMS. There is some questions I cancelled it. Okay, so this sheet is the important for you to be ready for the quarter exam. During a science experiment, a student dropped a metal pole from a height of 150 meters. The graph shows the distance the metal pole traveled from its initial position to where it hit the ground. Okay. This is 0 point is the initial point or the start point. This graph represents the metal pole during its fall from the 150 meters height. You can find that if you move with this line, you can find that the speed of the metal pole will increase, start from 0 and reach 160. So the right answer is B. The speed of the metal pole increases over time. By the time it passes, the speed of the metal pole increases. The second one, in a swimming race, you swam the first 50 meters. So we have first 50 meters in 42 seconds. Okay, this student swam the first 50 meters just in 42 seconds. She swam, okay, me with a girl. She swam the second 50 meters in 40 seconds. So the race is divided into two distance. The first distance 50 meters, the second distance 50 meters. Okay, she covered the first 50 meters in 42 seconds and the second 50 meters in 40 seconds. The question is, what is the average speed during the race? We say that average speed equal total distance divided by total time. Total distance divided by total time. So you can calculate the average speed by added the distance with each other. 50 plus 50 equal 100. Excellent. Divided by total time, which is 42 plus 40 equal 82. So 100 divided by 82, it will be 1.21 and will be approximate to 1.22. The next one, but which unit is used to measure distance? We say that distance measured by different measuring units like centimeters, meters, kilometers. So the choices: grams, seconds, milliliters, centimeters. So we will choose centimeters. The next page, acceleration, the second lesson in our curriculum. The meaning of acceleration, you must know that the change in the speed during time. If the speed doesn't change, no acceleration. That means we know that we have types of speed. The speed may be constant or regular, which means the speed doesn't change. For example, during your trip, you move by 100 kilometers per hour with your car. So your speed doesn't change, still 100. If your speed change from 100 to 120 to 150, so the speed change. This speed is called irregular or non-uniform speed. So we have two types of speed. One of them, the speed constant, doesn't change. The second one, the speed change. Okay? So acceleration related to the speed which changed. So when the speed, again, when the speed change, there is acceleration. When the speed doesn't change, no acceleration. Okay, clear? Okay. The question, which scenario doesn't describe an example of acceleration? We have different choices. Which one of them explain or describe acceleration? We had deal with each other. Acceleration means a change in the speed. Okay? Don't forget this. Number one, car increases its speed while turning to the left. Okay, the speed increases while turning to the left. Okay, so the speed change in this case. Second one, car decreases its speed, so the speed change. Number C, car maintains constant speed while turning to the right. D, car maintains a constant speed while driving straight ahead. Okay, back to the question. The question asks about not describe acceleration. No acceleration. In the first one, the car speed increase, so there is acceleration. In second one, the car speed decrease, also there is acceleration. And letter C and D, there is constant speed, but in number C, there is change in the direction. There is change in the direction, while in number D, the direction doesn't change, so we will choose the last one. No change in the direction, no change in the speed, so number D doesn't represent an acceleration. Number two, measuring acceleration requires appropriate units, which are the SI units for acceleration. Simply, the question asks about the measuring unit of acceleration, as I said that at the beginning of the video. The measuring unit of acceleration, meter per second power 2 or kilometers by hour power 2. Number 3, which of the following is an example of acceleration? Example of acceleration. The first question, no acceleration, okay? No acceleration. Okay. Number, the first letter A boat sits on a boat trailer. So, number B, car moves in a straight line at 60 km per hour. Number C, a plane moves in air at a steady speed of 850 km per hour. Number D, a bus moves on straight road and then makes a right turn. If you not exact, the first letter, no speed. The boat sits on a boat trailer, doesn't move. So acceleration equals 0. And second one, car moves in a straight line at 60 km per hour. So in same direction with the same speed, so the speed doesn't change. So in this case, no acceleration. But we ask about example of acceleration. Number C, a plane moves in air at a steady speed. A steady speed, so the speed doesn't change. So, the last one, moves on a straight road and then makes right turn, so the direction change. And the speed will change, so the right answer, letter D. Number 5, Rihaka conducted an experiment with a radio controlled toy car. The sketches show her findings. What is the average speed? Okay, from this figure we want to calculate the average speed. The first figure, V1 equal 20 meters per second. This speed takes 0 time. Okay? The second figure, V2 equal 30 meters per second in 2 seconds. We see that acceleration equal V2 minus V1 divided by time. Again, V2 minus V1 divided by time. The time in this problem equal to just 2. 0 plus 2 equal to. So V2 minus V1 over time, V2 30, V1 20, 30 minus 20 equal 10, and the time 2, 10 divided by 2 equal 5. So the right answer will be 5 meter per second. The third lesson, forces. The meaning of force when you act on something by pull it or push it, you can make it moves or not. Why? Maybe your power or your force is improper to move it. For example, when you push the wall, it doesn't move. Right? Right. So your force is improper force to move the wall. But if you push your toy car, it will be moves because your force is proper. So to be understand, the main point of the forces lesson is the net force. The net force. What is the meaning of net force? The net force means all the forces that act on the object in the same time. Again, net force is all forces that act on the same object on the same time. Maybe these forces act in the same direction, like this, and maybe the forces act in opposite direction. So, how can I calculate the net force? You can calculate the net force in the case of same direction by adding all forces together, plus plus plus. Okay, if the forces the forces are in opposite direction, so you can calculate the net force by subtract the small force from the bigger one. In this figure, the forces that act on the object are in the same direction, so the net force is added 50 plus 50, so it will be equal 100. Okay, next one. Which of the following is considered a contact force? Considered as a contact force, the meaning of contact force means the two surfaces or two objects must be in case of touching or touching each other. For example, when you rub your hand together, rub your hand together, both of them together, touching each other, and rubbing, so you will feel by heat during the friction that occurs between your hands. So contact force must be the two surfaces which contact to each other must touching each other. Number one, the force between two magnets. Okay, we have two magnets. Before the attraction that occurs between the two magnets, they don't touching each other, right? Number B, the gravitational pull of a planet. For example, the gravitational force between Sun and Earth planet. Does the Sun touching the Earth planet? Of course not. So their contact force is not found between them. Number C, the friction between an object and air. Okay, for example, the car moves in the road touching the air. The plane moves in the sky touching the air. Right? The bird fly in the sky touching the air. So there is a touching between the surface of the plane or the surface of the bird body or the surface of the car tire and the air surface. So we will choose number C. Okay. Number D is a force between two charged particles. Charged particles related to the electric current, the electricity. When you look at the dry cell that used inside the remote of the television, you can notice that the dry cell have two poles. One of them have positive charge and another one have negative charge. So negative charge and the positive charge, they are doesn't touching each other. So the right answer just number C. Two equal forces act in opposite direction. Okay, so the equal forces act in opposite direction will be added to each other. In opposite direction on object A. On object A. Two unequal forces act, so sorry, in opposite direction, so it will be subtract, sorry. Two unequal forces act in opposite direction on the object B. We have two objects now, object A and object B. If these are the only forces acting on object A and B, which of the following conclusion is true? Okay, we have two objects A and B. Each one of them acted on it two forces, but in case of object P, the two forces is unequal, but in case of object A, the two forces are equal. Okay, so when you subtract the two equal forces from each other, it will give 0. Excellent. But in case of object B, it will be number more than 0. So object B will accelerate, not object A. You got it? Okay, the result of net force on object A will be 0, but in object B will be more than 0, so the right answer number B. The last question in this revision, Jessica has two poles. One pole has a mass of 1 kilogram. The other pole has a mass of 2 kilogram. We have two poles. The first one, its mass 1 kilogram. The second one 2 kilogram. She pushes each with a force of 100 Newton. Okay. How does the acceleration of the two poles compare? Okay. The force equal mass multiply acceleration. Again, force equal mass multiply acceleration. But in this question, we want to calculate the acceleration of each one of them. So acceleration will be calculated by divided the force over mass. So again, to calculate the acceleration, you must divide the force over mass. We note exact the force in the case of the two poles are similar. Okay, 100 Newton. But the mass of each one of them different. The mass of first pole 1 and second one 2. So 100 over 1 equal 100. 100 over 2 equal 50. So the acceleration of the two poles compare. Maybe the first one, which have 1 kilogram, accelerate as same as 2. Number P, letter B. The 1 kilogram pole accelerate have as much as the 2 kilogram. Number C, the 1 kilogram pole accelerates twice as much as the 2 kilogram pole. So it is right answer, because we calculate that the mass of the acceleration of 1 kilogram pole is 100, and the acceleration of the 2 kilogram mass pole 50. So 100 is twice or double 50, so the right answer will be letter C. Okay, so in this revision we start the revision on the lesson 1, which is speed and motion, and lesson 2, which is acceleration, and the third lesson, which is forces. So we still have 2 lessons in this quarter: lesson power, work and energy, okay, and lesson potential and kinetic energy. I will explain them in the next revision video inshallah. See you next time.